Hello, good morning students. Today we discuss complex numbers problems. Now the first problem, the value of I square plus I to the power of 4 plus I to the power of 6 plus up to so on 2n plus 1 terms. Here number of terms odd number because 2n plus 1. If suppose n equals to, take 1, if n equals to 1, for implies what is the 2n plus 1 equals to, we get 3. Now number of terms equals to 3. If suppose n equals to 0, 1 term, n equals to 3, we get 7 terms, n equals to 2, 5 terms, so on. Now if suppose n equals to 1, take it, number of terms 3. That first 3 terms equals to I square plus I to the power of 4 plus I to the power of 6. But I square equals to minus 1. I to the power of 4 equals to 1. I to the power of 6 equals to minus 1. Now that equals to minus 1. Answer is minus 1. Now first option. Next, second problem. Sigma n equals to 0 to infinite, it is not infinite, 2i by 3 whole to the power of n equals to. Now sigma nothing but summation. Now first n equals to 0 substitute, we get 1, n equals to 1, 2i by 3 plus n equals to 2, 2i by 3 whole square plus 2i by 3 whole cube up to so on infinite. Now it is geometric progression. Here first term a equals to 1, common ratio r equals to 2i by 3, common ratio r equals to 2i by 3. Now s infinite equals to, in infinite geometric progression, sum of infinite terms equals to a by 1 minus r. That equals to, here the value of a is 1 by 1 minus 2i by 3. Take LCM as 3, we get 3 by 3 minus 2i. Now multiplied and divided by conjugate of denominator 3 plus 2i by 3 plus 2i. That equals to, we get 9 plus 6i by a minus b into a plus b, a square minus b square, 3 square minus 2i whole square, or that equals to 9 plus 6i by 9 plus I square equals to minus 1, minus of minus plus 2 square 4, 3, 9 plus 4, 13. Now 9 plus 6i by 13. Now first option. Next, third problem. If sigma k equals to 0 to 200, I to the power of k plus pi of p equals to 1 to 50, I to the power of p equals to x plus iy. Now require the value of x comma y, x and y values. Okay, here sigma nothing but summation. The value of k equals to 0 to 200. Now k equals to 0, substitute 1 plus I power 0, 1. Next to k equals to 1 I plus I square plus I cube plus up to so on I to the power of 200 plus, here pi nothing but product of terms from p equals to 1 to 50. P equals to 1, substitute I into I square into I cube, I to the power of 4 up to so on I to the power of 50. I to the power of 50. Pi nothing but product of terms, sigma nothing but sum of the terms. Okay. Now in complex numbers, always first four terms I plus I square plus I cube plus I to the power of 4, it is equals to 0 always, because I square equals to minus 1, I cube equals to minus I to the power of 4 equals to 1. Now its value equals to 0. Every 4 terms 0. Now here I to the power of 4. This first group 0. Similarly, I to the power of 5 plus I to the power of 6 plus I to the power of 7 plus I to the power of 8. It is also 0. Now up to 200 we get such groups 50 groups. Now this complete value equals to 0. Now this value equals to 1, only 1. Remaining complete terms equals to 0. 1 plus I to the power of 1 into I square plus I to the power of 3 up to so on I to the power of 50. That equals to I to the power of 1 plus 2 plus 3 plus up to so on 50. Now 1 plus I to the power of sum of first n natural numbers equals to n into n plus 1 by 2. N into n plus 1 by 2. But here n equals to 50. 50 into 51 by 2, or that equals to 25 into 51. Now 25 into 51, that equals to 1 plus I to the power of 25 into 51. 25. 1275. 1 plus 2 plus 3 plus up to so on 50 equals to 1275. That equals to 1 plus 1275 divided with 4, we get 4 3 is the 12, 7 take it 1, 35, 8. Now it is equals to I to the power of 4 into 318 into I cube. That equals to 1 plus I to the power of 4. I to the power of 4 equals to 1. 1 power 318 equals to 1. Now only I cube. 1 minus I. Sorry. 1 minus I. But it is given x comma y. X plus I y. Sorry. Equals to x plus iy. Therefore, equate to real and imaginary parts. Now, x comma y equals to 1 comma minus 1. 1 comma minus 1. Now, second option is correct. Next, third problem. N belongs to natural numbers. 1 plus I by root 2 whole to the power of 8n plus 1 minus I by root 2 whole to the power of 8n equals to. Now 1 plus I by root 2 whole to the power of 8n, it can be written as 1 plus I by root 2 whole square to the power of 4n. 4n. Because 8n can be written as 2 into 4n. Similarly, second one, 1 minus I by root 2 whole square to the power of 4n. Now 1 plus I whole square, a plus b whole square 1 plus I square plus 2I by root 2 whole square 2 to the power of 4n plus 1 plus I square minus 2I by 2 whole to the power of 4n whole to the power of 4n. Now here 1 I square equals to minus 1 plus 2I by 2 whole to the power of 4n plus 1 I square equals to minus 1 minus 2I by 2 whole to the power of 4n. Minus 1 plus 1 get cancelled. We get 2I by 2, that equals to I to the power of 4n plus minus I to the power of 4n. It also can be written as I to the power of 4 whole to the power of n plus minus I to the power of 4 to the power of n. But I to the power of 4 equals to 1 power n minus I whole to the power of 4 also 1, because even exponent positive value we get to the power of n, that equals to 1 plus 1 equals to 2. Answer is 2. Third option. Next, the condition for the cube of a plus ib to be real number. A plus ib, cube of a plus ib or a plus ib whole cube, a plus ib whole cube, it is be a real number. Now a plus b whole cube expansion, a cube plus ib whole cube plus 3a square ib plus 3a ib whole square, that equals to a cube. Here ib whole cube equals to I cube b cube, but I cube equals to minus I b cube plus 3a square bi I square equals to minus 1 minus 3a b square minus 3a b square. Now that equals to a cube minus 3a b square. In remaining terms minus I take common, in these two terms I common, we get I of 3a square b minus b cube. But in problem given it is real number, then imaginary part equals to 0. Here real part is a cube minus 3a square b and imaginary part 3a square b minus b cube. It is purely real, then imaginary part equals to 0, means 3a square b minus b cube equals to 0. For implies b take common, 3a square minus b square equals to 0. Now b equals to 0 or 3a square minus b square equals to 0. Now 3a square minus b square equals to 0, for implies 3a square equals to b square. Now b equals to plus or minus a root 3, b equals to plus or minus a root 3 and b equals to 0, b equals to 0, b equals to plus or minus a root 3, b equals to 0 and b equals to plus or minus root 3a. Third option is correct. Next, if z equals to, here given z equals to 3 plus 5y, require the value z cube plus z plus 198 equals to, require the value of z cube plus z plus 198. Given z equals to 3 plus 5y. Now z cube equals to, cubing on both sides, 3 plus 5y whole cube. Now a plus b whole cube, a plus b whole cube expand, we get 3 cube plus 5y whole cube plus 3 into 3 square into 5y, 3a square b plus 3ab square, 3 into 5y whole square. Now that equals to 3 cube 27, 5 cube 125, I cube equals to minus I, minus 125I. Next to here 3 square 9 into 3, 27 into 5. Plus 135 I. Here I square equals to minus 1, minus 3 into 3, 9 into 5, 225. I square equals to minus 1. Now that equals to minus 225 plus 27, that equals to minus 198, minus 125i plus 135i plus 10i. It is z cube equals to minus 198 plus 10i, but required z cube plus z plus 198, but z cube equals to minus 198 plus 10i plus z equals to 3 plus 5i plus 198. Minus 198 plus 198 get cancelled, that equals to 3 plus 10i plus 5i, 15i. 3 plus 15i. Option D. 3 plus 15i. Next problem. If x plus 3i by 2 plus iy equals to 1 minus I. Now require the value 5x minus 7y whole square equals to, means require the values of x and y. Now cross multiply x plus 3y equals to 1 minus I of 2 plus iy. Now x plus 3i equals to, multiply these two factors, 1 into 2 plus iy minus 2i minus I square y. Now x plus 3i equals to 2 plus, in these two terms I take common, I of y minus 2, I square equals to minus 1, minus of minus plus 5, means x plus 3i equals to 2 plus y plus I of y minus 2. Now equating real and imaginary parts. Equating real parts and imaginary parts. Equate real parts, x equals to 2 plus y. It is considered equation 1. X equals to 2 plus y. Next imaginary parts, equate 3 equals to y minus 2. 3 equals to y minus 2 for implies y equals to 5. Y equals to 5. The value of y equals to 5 substitute in the first equation, then we get x equals to 7. Y equals to 5, x equals to 7. Required 5x minus 7y whole square equals to, here x equals to 7. Substitute 5x equals to 35 minus 7y equals to also 35 whole square, that equals to 0. Now option is second option. Next, eighth problem. If x plus iy into 2 plus 6 theta equals to 3. Required the value x square plus y square minus 4x plus 3 equals to. Now here given x plus iy into 2 plus 6 theta equals to 3. Now x plus iy into 2 plus 6 theta nothing but cos theta plus I sin theta, cos theta plus I sin theta equals to 3. Now required the value of x square plus y square minus 4x plus 3 equals to, put theta equals to any known value, put theta equals to, if suppose 0 degrees, x plus iy into 2 plus cos 0 is 1 plus I into sin 0 0. Now x plus iy into 2 plus 1 3, but it is equals to given 3. 3 cancel on both sides, we get x plus iy equals to 1. X plus iy equals to 1. 3 cancel, x plus iy equals to 1. 1 nothing but 1 plus I into 0. Equate real and imaginary parts on both sides. Therefore, x equals to 1, comma y equals to 0. X equals to 1 and y equals to 0. Now substitute the values of x equals to 1 and y equals to 0. 1 square plus 0 minus 4 plus 3, that equals to 4 minus 4 equals to 0. Answer is 0. First option. Next, the non-zero complex number z satisfies z equals to I into z square, I into z square. Now given options, first option I, second option minus I, third option 1 plus I, fourth option D 1 minus I. Now verify options. If suppose z equals to, take first option, z equals to I, how much you get? I equals to I into I square. I equals to I square equals to minus 1 minus I. Now I equals to minus I, wrong. Therefore first option is wrong. First option wrong. Next to verify second option. If z equals to minus I, z equals to minus I. Now z equals to I z square, that equals to minus I equals to I into minus I whole square. Minus I equals to I into minus I whole square, even exponent, I into I square. Minus I equals to, but I square value minus 1 minus I. Now it is satisfies, both sides equal, then option B is correct. Next, 10th problem. The conjugate of the complex number is 1 by I minus 1. 1 by I minus 1. Now it is equals to 1 by minus 1 plus I. Now if suppose A plus IB is a complex number, now conjugate of A plus IB is A minus IB. Conjugate of A plus IB is A minus IB. Therefore conjugate of 1 by minus 1 plus I equals to 1 by minus 1 minus I, minus 1 minus I. That equals to 1 by minus take common minus of 1 plus I, that equals to minus 1 by 1 plus I, minus 1 by 1 plus I, or I plus 1. Now third option is correct. The complex number 1 plus 2I by 1 minus I lies in the quadrant number, first quadrant, second quadrant, third or fourth. Now 1 plus 2I by 1 minus I, given complex number. Now multiply conjugate of denominator 1 plus I by 1 plus I, or that equals to multiply first two factors in numerator, 1 into 1 1 plus 1 into I plus I plus 2I into 1 plus 2I plus 2I square by a minus b into a plus b, a square minus b square, 1 square minus I square, that equals to 1 plus I plus 2I, totally 3I, 2 into I square value minus 1, that equals to minus 2 by I 1 square 1, I square equals to minus 1, minus of minus plus 1. Now 1 minus 2, that equals to minus 1 minus 2, minus 1 plus 3I by 2, or that equals to minus 1 by 2 plus I into 3 by 2, I into 3 by 2. Now it is equals to x comma x plus iy. Therefore x comma y equals to x equals to minus 1 by 2, y equals to 3 by 2. Now x coordinate negative, y coordinate positive, x coordinate negative, y coordinate positive, then it lies in the second quadrant. Next, if sin x plus I cos 2x comma cos x minus I sin 2x are conjugate to each other, then x equals to, require the value of x. Now if suppose a plus ib is one complex number, then its conjugate is a minus ib. Therefore here sin x equals to cos x, because here real parts must be equal. Sin x equals to cos x. Next, imaginary part equals to minus of imaginary part of conjugate, means cos 2x equals to sin 2x. Sin x equals to cos x and cos 2x equals to sin 2x. Now sin x by cos x equals to 1, or for implies tan x equals to 1. X equals to pi by 4 or 45 degrees. Tan x equals to 1, x equals to pi by 4. Now next to sin 2x by cos 2x equals to sin 2x by cos 2x equals to 1. Now tan 2x equals to 1. But here x equals to pi by 4. From first equation x equals to pi by 4. Now 2x equals to how much you get? Pi by 2. 2x equals to pi by 2. Tan pi by 2 equals to tan 90 equals to infinite. Tan 90 not defined. Now that's why both equations satisfies for x, but here not satisfied, because sin pi by 2 equals to in right side 1, but that is infinite. Therefore no real values of x satisfying both equations. Sin x equals to cos x and cos 2x equals to sin 2x. Now third option 5. Next, z1 z2 are complex numbers such that z1 plus z2 is a complex number and z1 z2 is a real number. Then first z1 let Z1 equals to x plus Iy, Z2 equals to a plus Ib, Z2 equals to a plus Ib. Now Z1 plus Z2 is a complex number. Now Z1 plus Z2 equals to x plus Iy plus a plus Ib, or that equals to x plus a plus I of y plus b. Now next to Z1 Z2 is real number. Z1 into Z2 equals to x plus Iy into x minus Iy. Sorry. A plus Ib, that equals to multiply together Ax plus Ibx plus Iay plus I square by, or that equals to Ax plus, in these two terms I take common I of bx plus ay, but I square is minus 1 minus by, that equals to Ax minus by plus I of bx plus ay, bx plus ay. But given Z1 Z2 is real number, Z1 Z2 real number, then imaginary part equals to 0. Now bx plus ay, it must be 0. Now it is equals to only ax minus by. Ax plus bx plus ay equals to 0. Now here Z2 equals to Z1 bar. Now suppose take the options here. Z1 equals to, consider x plus Iy, Z2 equals to a plus Ib. Now Z2 equals to Z1 bar equals to x minus Iy, Z1 bar equals to x minus Iy. Now it is equals to Z2, Z1 bar equals to Z2. Now but Z2 equals to a plus Ib, means x minus Iy equals to a plus Ib. Therefore x equals to a, y equals to minus b. Equate real and imaginary parts. Therefore Z2 equals to how much we get? Z2 equals to, not necessary, just a minute. Take the first option, Z1 equals to, let Z1 equals to x plus Iy, Z1 bar equals to Z2, Z1 bar conjugate is x minus Iy equals to Z2. Now see it, what is Z1 plus Z2 equals to? Z1 plus Z2 equals to x plus Iy plus x minus iy, that equals to we get 2x, but it is only real. So that here z1 plus z2 is complex number, but it is real number. Therefore, first option is wrong. Next to take here z1 equals to x plus iy. Take the second option, let z2 equals to x plus iy, or implies z2 bar equals to x minus iy, but it is nothing but z1. z2 equals to x plus iy, z1 equals to x minus iy, z1 plus z2 equals to, also we get, z1 equals to minus z2 bar. Here z1 equals to, first for implies z2 bar equals to x minus iy, z1 equals to minus z2 bar, that equals to minus of x minus iy. Now therefore that equals to minus x plus iy. Now z1 plus z2 that equals to how much? Adding these two we get z2 equals to x plus iy, z1 equals to minus x plus iy, minus x plus iy plus x plus iy, that equals to 2iy. Now it is complex number, z1 plus z2 is complex number. Next to z1 into z2 equals to z1 nothing but minus x plus iy into z2 equals to x plus iy, that equals to here a plus b into a minus b, iy whole square minus x square, that equals to, but I square equals to minus 1 minus y square minus x square, or that equals to minus of x square plus y square. Now it is real number, therefore second option is correct. Next, the value of theta for which the expression 1 plus I cos theta by 1 minus 2I cos theta is a real number. It is real number. Now given complex number 1 plus I cos theta by 1 minus 2I cos theta. Now multiply and divide with conjugate of denominator. What is conjugate of denominator? 1 plus 2I cos theta by 1 plus 2I cos theta, that equals to how much? We get numerator 1 into 1 1 plus 2I cos theta plus I cos theta plus 2I square cos square theta by a minus b into a plus b, 1 minus 2I cos theta whole square, that equals to, what is numerator 1 2I cos theta plus I cos theta plus 3I cos theta, I square equals to minus 1 minus 2 cos square theta by 1 plus 4 cos square theta, because I square equals to minus 1. Now that equals to 1 minus 2 cos square theta by 1 plus 4 cos square theta plus 3 cos theta I by 1 plus 4 cos square theta. But in problem given it is only real number. Real number, then imaginary part equals to 0. It is real number, then imaginary part equals to 0. Now 3 cos theta by 1 plus 4 cos square theta equals to 0. Now cos theta equals to 0. Then theta equals to 90 degrees, pi by 2. Now general solution of theta. Theta equals to 2n pi plus or minus pi by 2. 2n pi plus or minus pi by 2. Third option. Next problem. Square root of 3 plus 4i plus square root of 3 minus 4i by square root of 3 plus 4i minus square root of 3 minus 4i equals to, require this value. Now first to find out square root of 3 plus 4i. 3 plus 4i. Let 3 plus 4i equals to x plus I by 3 plus 4i equals to x plus I by. Now squaring on both sides, we get 3 plus 4i equals to